Hey, Mr. Harridan here, dedicating this video also to you, Bill Murray, who is also Peter Venkman in Ghostbusters, just so you know. Today we get to talk about one of my favorite topics in the world here. This is the ultimate introduction to dimensional analysis. Where I show you where we're trying to go. And I've been trying to go for a while. Play.
There are some things in this world that go way beyond human understanding. Things that cannot be explained. Things that most people don't want to know about.
Well, this ain't one of them. Everybody wants to know about this. So, remember our mole ratio. This is our bridge that we use to go from one substance to another. That means somewhere in our calculation we're going to need a mole ratio, which also means we're going to need a chemical reaction. Okay? You're going to need a balanced chemical reaction. Now, back in the day in a land far away, I taught you that you can go from grams to moles using the molar mass, right? I also taught you to do atoms, formula, and molecules. You can use 6.022 times 10 to the 23rd, right? Because the molar mass, remember, it's grams over 1 mole, remember? And then these were atoms, molecules, and formula units over 1 mole. We've also done liters of gas at STP. Remember, that is 22.4 liters for every 1 mole. Okay. And I've introduced you from going from here to here to here for 2-step problems, or from here to here, or from here to here for 1-step problems. We are now going to try to do the ultimate here and do 3-step problems here, because there is a mole to mole ratio. There is actually a loop that you can do here as well. You can go from moles to moles with the mole ratio. And then you need your chemical reaction to do this. You need your coefficients. Right? And remember, your mole ratio is moles of B over moles of A, and these could be any number. Okay? So what I'm going to try to teach you how to do today is to do some 3-step problems here. So we're going to start here, go to the moles, go around the mole ratio, and then we can come back to mass or come over here, go different directions. Okay? There's a bunch of different ways to do this. Okay? Let's get on to page 12. Okay? I would play you some Bill Murray, but we need to be focused on this. This is very, very difficult. Okay, so let's look at page 12 here with my notes here. Okay, so you're going to see me draw a map, okay? There are 2 basic ways I do this. I either draw a map like this, okay? So in the map, you have to go down to moles, across the moles, and back up to grams, because you can't go across, because you can only go across the mole bridge. Remember, it's moles of A, or moles of B over moles of A. Okay? Or you're going to also see me do the checklist. There's also a checklist I sometimes do, too. My checklist is this. Step 1. Go to moles. Okay. Step 2. Mole ratio. Step 3. Go away from moles. Okay. That is how I solve all difficult stoichiometry problems. Step 1. Go to moles, because it's the heart of chemistry. Step 2, mole to mole ratio. Step 3, go away from moles. Okay, let's see what we got here. How many grams of bromine are required to completely react with 45.70 grams of lithium iodide? Okay, so the first thing we need here is a reaction here. So we got bromine. Bromine is Br2, right? Diatomic element. We are going to react that with lithium iodide. Lithium is Li, iodide is I. This is +1, this is -1. Okay. This is going to produce, since this is a single replacement reaction, right? Bromine is a nonmetal. Lithium is a metal. So we're going to put lithium with bromine. So this is LiBr. Remember, lithium is +1 and bromine is -1. And then we're going to have iodine, which is I2. To put in the state, well, I gotta put in the state symbols here. So this is a liquid here. This would be aqueous, according to the solubility rules. This would be aqueous because these both have group 1 in it. And iodine is a solid. Okay. Now I am going to make a map to teach you how to make a map here. So, we are looking for grams of bromine. That's what I'm looking for. Okay. We are starting off with 45.70 grams of lithium iodide. Okay. We cannot go straight across from here to here because we have to go through the mole bridge. Okay. And I didn't balance the reaction still. There's 2 iodines here, so I need to put a 2 here, correct? And I need to put a 2 there, correct? That's correct. So first step is to go down to moles of lithium iodide. You will do that with the molar mass of lithium iodide, right? Because you got to use molar mass here. Then you're going to go over to moles of bromine, because we got to do our mole ratio changing room. That's step 2. And step 3, we're going to multiply by the molar mass of bromine again. Okay. So here we go. Fun for everyone. So we are starting off with 45.70 grams of lithium iodide. I have drawn 3 arrows, right? So there are going to be 3 steps. Okay. Grams on the top, grams on the bottom. What am I going to convert to? Moles. These units are different, so we're going to use the same substance, lithium iodide and lithium iodide. Swish, swish. What number goes by moles? 1. What number goes by lithium iodide? You have to do one of these things. 1 times 6.94 equals 6.94. 1 times 126.91 equals 126.91. 126.91. I think this is 90. It's 90. So then we're going to get a molar mass of 133.84 G/moles. Down with the gangsters. So this is actually the flipped gangster here. 133.84 goes right there. Okay. That is step 1. We have gone to moles. Step 2 is the mole to mole ratio. Moles on the top, moles on the bottom. What are we going to convert to? Moles. That don't make sense. So that way we have to look at the substances. Lithium iodide up here. We are trying to get to grams of bromine. So we need to put moles of bromine up here. Then we do our classic wham, 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 whams. Wham, 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 wham. 1. Wham, 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 wham. 2. So we have done step 2, the mole ratio. Step 3, swish, swish. Step 3, moles on the top, moles on the bottom. What are we going to convert to? Grams. Since the units are different here, we're going to use the same substance, which is bromine. 1 mole of bromine. Oh, we got to use that molar mass of bromine, of course. Just 2 times 70.90, which is 159.8 G/moles. That number goes right here. Multiply, divide, multiply, divide, multiply, divide. You get an answer. You're rounding to 3 sig figs. So my final answer for this one is 27.28 grams of bromine. Okay. I'm going to stop there because that was just one problem. I'm going to do the next 2 in the next video and the next 2 in another video. Guys are champions. The legend is